Okay. So, today we are still on microeconomics review and I have posted lecture notes 3A and 3B. You do not have any videos. Once again, this is something that some people do not cover in a principles class. We usually do it in intermediate level microeconomics, but some people would do it. So, I am going to do it in your class because you need it. I would not have done it in my principles class, but we are not going to go into too much of details, just like elasticity. We are just going to do stuff that you need for understanding the Grossman model later on. Okay. So, this is about utility maximization. Now, what do I mean by utility maximization? Now, on day 1 we started, when we started lecture note 1, we said that every individual is taking a decision based on his cost benefit analysis. So, he is weighing the benefits and the cost at the margin. So, another name for benefit is basically utility, okay? Utility or satisfaction. So, you do something because you think that you have certain satisfaction from it. You can derive some amount of satisfaction. Now, as you understand, satisfaction is a very subjective concept. If I ask you, if you drink a glass of water, how much satisfaction will you get? It is very difficult for you to quantify it. It is not something that can be quantified. So, utility in that sense is a very subjective concept, and subjective in the sense that it is not quantifiable. Okay. But in econ, we try to quantify everything. So, just for making things easy for us to understand, we try to quantify utility with numbers, where it just means that if I have a numerical value of utility higher than somebody else, then I am just getting more satisfaction out of it, as simple as that. So, if I say I have utility 5 and she has utility 4 from a glass of water, it means I have a higher satisfaction from consuming that glass of water than her. Okay? And we have a unit for utility in econ, which is simply called utils. So, utils is the unit for measuring utility. So, when I say that someone is getting utility 5, it just means it is 5 utils. Okay? But like everything else in econ, also for utility, we are not so much worried about the total utility, but we are worried more about marginal utility, that is utility at the margin. And like every other marginal concept, the meaning of marginal utility is how much utility, how much satisfaction do I derive by consuming one extra unit of any good or service, one additional. Okay? So, that means what am I trying to say? If I give you an example, if I have bottles of water and if I have total utility and marginal utility. Okay. So, the first bottle of water, let us say, has 10, second bottle of water, obviously my total utility will increase because I am having more water. So, let us say 18, third bottle of water, let us say 23, and I am just cooking up those numbers, it does not have any relation whatsoever. The fourth bottle of water, let us say 25. Okay. So, each time please note that total utility is increasing. Why? Because I am just consuming more of a commodity, right. If there was no additional benefit, if my benefit was not increasing overall, then I would not be consuming that commodity in the first place, right. So, just because I am getting more of the commodity, my benefit or utility from it is increasing overall. But that does not necessarily mean that the marginal utility is increasing. That means with every additional, each time you add one, it does not mean that that extra unit of the commodity is giving you additional satisfaction. So, we do not have something called 0, right, 0 is nothing, you are not consuming anything. So, basically whatever you get from the first one, whatever total you get from the first one, that is your marginal for the first one also, because that is what you just get from the first one, right. There was no reference point before that. Now, you go on to the second one, how much are you getting just from the second bottle? Not 2, you are getting 18 minus 10, that is 8. How much are you getting just from the third one? So, 23 minus 18, 5. Okay. Similarly, how much are you getting just from the fourth one? 25 minus 23, which is equal to 2. So, you can see that although total utility is increasing, the marginal utility is not. What does that mean? That means that as you consume more of a commodity, that commodity will definitely give you some benefit and hence your total will increase, but it is not necessary that the marginal will increase. Okay. That means every time you consume more of a commodity, your level of satisfaction is increasing, but it is increasing at a decreasing rate. That is what it means. It is increasing, but it is increasing at a decreasing rate. The increment is getting smaller every time, right. This is also known as law of diminishing marginal utility, LDMU. Whatever I just told you right now, that is called law of diminishing marginal utility. That means, as you go on consuming more of a commodity, the marginal utility from every additional unit keeps decreasing. Law of diminishing marginal utility. Okay. Now, why is this concept of utility so important? Why are we making such a big deal about utility? We are making a big deal about utility because that takes us back to actually the concept of scarcity. You cannot have it all. There is scarcity of resources, and by resources in this context we mean there is scarcity of the money in your pocket, there is scarcity of time at your disposal. So, given time and given your purchasing power or money, you have to make the best possible choice for yourself. And how do you make the best possible choice for yourself? You choose the commodity which you think will give you the maximum satisfaction, right, which will give you maximum utility. So, if you were to choose between two goods, let me call those goods X and Y. In the real world, you know that your choice is between several goods and services, right, hundreds and thousands of goods and services. But here in the economics class, since we always try to represent something in terms of graphs, we cannot draw a multi-dimensional graph, we can only draw a two-dimensional graph. So, that is why for simplicity we are assuming that in the world there is only two goods, there are only two goods and you have to choose between those two goods. But in the real world you actually make a choice between several goods. And if I could draw a multi-dimensional graph on the board, then it would be multi-dimensional. But for simplicity and for graphical representation, we are assuming that an individual has to choose between two goods X and Y. Okay. So, he will try to choose the good, he will try to choose one of the goods, or he will try to choose a combination of the two goods or service based on the utility maximization. What gives him the maximum utility? Okay. Is that clear? Now, so we have two goods and the prices of these two goods are given as Px. So, the price of good X is Px and that is a dollar value, and you have a price of good Y, let us call that Py, and that is a dollar value. Okay. And when I say goods and X, goods X and Y, let me say that you buy X units of good X, so that is a numerical value, and the person buys Y units of good Y. Okay. So, that means how much, if I ask you how much money, and these are unit prices. Okay. So, Px and Py are all unit prices. So, if I ask you how much do you spend on good X, your answer will be Px times X, right. If I tell you that you buy 10 apples and each apple is $2, then how much did you spend on apples? 2 times 10, right. That is the concept that we are using. Similarly, how much is your total spending on good Y? If I ask you, it will be Py times Y, correct? So, that gives you the total expenditure on these two goods. And next, if I tell you that you spend all your income on these two goods, you do not save anything. These are the only two goods available in the world, and whatever you earn, you spend on just these two goods. Then can I say that Px times x plus Py times y will be equal to your total monetary income M, where M is your monetary income? Can I say that? Assuming that you do not save anything. So, if you have $100 and you spend those $100 on two goods and you do not save anything, then the $100 must be split between expenditure on good X plus total expenditure on good Y, where total expenditure on good X must be the unit price of good X times the number of X bought plus unit price of good Y times the number of Y bought, right. That is exactly what this means. Now, please note that this equation that we have right here, this is kind of a constrained equation. What do I mean by constrained equation? It means that it is constrained by something on the right hand side. That means the left hand side value cannot exceed capital M, isn't it? It is like constrained by M. M is putting a constraint on this. So, this is also known as the equation of the budget constraint or budget line. Budget constraint or budget line. Okay. More intuitively, what does that mean? More intuitively, it just means that every individual, if an individual had to make a choice between buying two goods, X and Y, right, and he has to decide how much of good X can I buy and how much of good Y can I buy, then he is constrained by the money in his pocket. He cannot buy as much as he wants. He is constrained by his budget, as simple as that. Okay. Now, if we represent this budget line graphically like we always do, we did for the demand curve and so on and so forth. If we try to represent this, so you understand that this is looking something like an equation. This is an equation of a straight line, right?
I'll understand it once we put real numbers in there.
5x plus 10y is equal to 100. Let us say 5 times x plus 10 times y is equal to 100. 100 is your monthly income. 5 is the price, unit price of x. 10 is the unit price of y. Okay.
What's X number of units?
Units.
Okay.
So, if x is apples and y is oranges, right, I told you that you can buy, you bought 10 apples and you bought 10 oranges. Okay. Price of apples is $5. Price of oranges is also $5 and your income is $100. Now, if we had to represent this budget constraint in a two-dimensional space, then now my choice is between the two goods, right. The choice is between x and y. I am choosing between x and y and I am splitting my budget between these two goods. So, what I am going to measure on the two axes has to be the quantity of the two goods. It is no longer going to be price and quantity of one good, because now it is the space for me is two goods. So, I have to capture both the goods here. I cannot just capture one good. So, please note, unlike the demand supply chapter, here on both axes you are measuring quantity. You are not measuring price. You are measuring quantity of x on one and you are measuring quantity of y on the other. It is quantity on both axes and it does not matter which one you measure along which axis. You could interchange that. You could measure x on, I mean, you know, what I am trying to say is, let us just change it to some names. I think it will be easy. Let us say apples, that is your x, and oranges, that is your y. Okay. So, what I am trying to say is you could measure apples on y axis and you could measure oranges on x axis, it would not matter. Okay. Now, coming here, so if I take a point on this axis, if I take a point on the x axis, what does that mean? That means the y coordinate is 0, is not it? Any point on the x axis means that the y coordinate of that point is 0, correct? So, if the y coordinate is 0, if this y is 0 right here, what will be the value of this x? Can you tell me? Px times x plus this will boil down to 0, is not it? Plus 0 is equal to m if y is equal to 0. Therefore, x will be m divided by px, correct? That means the number of apples that you can buy has to be your total income divided by the price of apples if you do not buy any oranges. That is what it means. If you do not buy any oranges, then your entire $100 gets spent on apples because there are no savings. And how will you find out that how many apples did you buy? You will just take your whole income and divide it by the unit price of apples, isn't it? Right? So, can I say that on the x axis, the coordinate of this point is m divided by px times 0? Sorry, not times, comma 0. Similarly, if I was not buying any x, if I was not buying any apples, if I was just spending on one good, right, then that means I would be buying something on this axis because I would be buying oranges only and my x coordinate would be 0 for sure because I am not buying any x. And then what would be my y coordinates? The same way I would do, the first term would become 0 plus py times y would be equal to m. Therefore, y would be m divided by py. The same thing, the same logic, right. So, then so it's simply put, if I do not look at those numbers, if I just look at this, if I just try to get the intuition behind it, what I am trying to say so far, the gist is you have a money income, that money income is your budget, you cannot spend anything more than what you earn, you are constrained by your monthly earning or your budget, right. If we consider a very simple situation where you do not save anything, then this budget also defines how much you can spend on goods and services, correct. If you earn $5,000 a month and you do not save anything, then the $5,000 basically tells you your limit for your spending, isn't it? Now, I am putting in another restriction and saying that these $5,000 you have to spend on just 2 goods or services, and those 2 goods are x and y, apples and oranges, right. So, you can have 2 extreme situations. The first extreme situation is point A, something like point A, where you only spend on apples, and the other extreme situation is point B, where you only spend on oranges. That is also possible, correct. I can think that I am going to spend my money only on one good, I do not need the other. So, I am here and there may be somebody else who thinks I do not need this, I need the other one only. So, these are basically 2 corner points or these are 2 extreme points. So, that means if a person wants to choose this point or that point, he is basically kind of specializing his taste in just that one good, whichever he is deciding to buy. He is not getting any of the other good, right. But please note that any other point, if I take any other point on this line, whichever it may be, there may be numerous points on that line, every other point on that line will be some combination of the 2 goods, isn't it? Some amount of apples and some amount of oranges. If I take a point here, it will have some x coordinate, it will have some non-zero y coordinate, and that will be true for any other point on that budget line, correct? But given this equation, whatever may be the values, whatever may be the amount of the two goods I am buying, it will always be constrained by that. Given that, it can never be less, given that it can never be more. It always has to exhaust the entire amount of my money, income or budget. Do you see what I am saying? Now, these combinations, all these combinations are called consumption bundles. Consumption bundles. What do I mean by consumption bundle? Consumption bundle just means some combination of x and y, some combination, okay, some amount of x, some amount of y, and that some amount could be a 0. So, that means these are also consumption bundles. It is just an extreme consumption bundle. This and that, A and B, are two extreme consumption bundles where you have 0 amount of one good, okay, that is also possible, right. But the consumption bundles have to be such, given the budget constraint, the consumption bundles have to be such that they exhaust your entire budget. It is never more or never less. Is that clear? Okay. Now, and the line that passes through all these consumption bundles, this is basically your budget line. So, that is basically the graphical representation of that budget constraint. So, this is like an equation of a straight line, isn't it? In math, if you think about a straight line, this looks like Ax plus By is equal to C, isn't it? Where x and y are two variables, A, B and C are three non-zero constant numbers mathematically, and if you plot that straight line, if you try to plot that equation of the straight line, it will look like that. So, that is exactly what we are doing. We are just plotting that equation of that straight line. And if you plot the equation of that straight line, you will have two corner points of that straight line. Those two corner points are the two extreme consumption bundles. By extreme consumption bundle, I mean that you are not consuming one of the goods at those points, you are just consuming one, and you will have some non-extreme consumption bundles, where the non-extreme consumption bundles just mean you have a certain combination of x and y, a certain amount of x and a certain amount of y that is consumed. Do you have any questions up to this point? Yeah.
What's the B and L? I'm sorry.
What is what?
Budget line.
Budget line. Yes.
Could you explain that extreme consumption bundles again?
Extreme consumption bundles are something like A and B, which means you have 0 amount of one goods, at least one good is 0. That is what it means by extreme, those corner points. Okay. So, now, so we know that the individual, any individual, if he is given to choose between x and y and he has a money income of m, he will operate on one of those points on the budget line, isn't it? He cannot get something that is here, because that is beyond his budget, and he cannot get something that is here because he is constrained by m. We assume there is no savings, he cannot save anything. So, that means a person has to get something which lies on this budget line. Now, it can be there, it can be here, it can be anywhere on that line, but his consumption bundle, his choice must lie on that line. Is there anybody who does not agree with that? Is there anybody who does not understand why it cannot be here, why a consumption bundle like this cannot be attained by this person, and why a consumption bundle like this will not be attained by the person? D will not lie on the line, which just means that there will be some amount of savings, and we assume that there are no savings. Okay. And C is just outside the budget. Okay. So, everything has to be here. So, the next step to this is we need to figure out that where exactly on this line will the person lie. Where does the person choose his optimum consumption bundle? So, there can be numerous consumption bundles, but which is the best one? So, we are trying to figure out what is the optimum consumption bundle. Okay? That will be the next step. But before we go on to finding out the optimum consumption bundle, we need to see that how is the budget line affected by the income and the price of the goods. We need to see that first. Then we can go to optimum consumption bundle. So, here in that equation that we had, Px times x plus Py times y is equal to m, there were two or three variables, right. You don't know, the price of the good can change, your monetary income can change. So, now we are going to see that how does the budget line get affected because of changes in price of the goods or due to the change in the monetary income. Okay? That is what we are going to do. Let us see for change in Px. Okay. So, you can have two cases under change in Px. Your Px can increase, price of commodity x can increase, or price of commodity x can decrease, correct? Those two things can happen, agreed? Now, let us say the price of commodity x, the first case, the price of commodity x has gone up. If the price of commodity x goes up, are you going to buy more of x or less of x? How many are saying more? Anybody saying more? Law of demand, if price of x goes up, you are going to buy less of x, isn't it? Where are you measuring the quantity of x? Where is quantity of x being measured in this diagram? On the x axis, correct? So, you are measuring it this way. So, that means now you cannot consume that much amount of x, you have to consume some less, isn't it? Is there any change in this point? Is there any change in that point?
If you're going to spend 100% of your budget.
No.
Let me just make it a little clean.
You're always going to spend 100% of your budget.
Let me make it a little tidy.
Yeah, so you're just buying less quantity. Yeah, you're actually the same.
This point is just m by px 0, that point is 0 m by py. Okay. Now, I am just saying that only what has changed is the price of x, and that price of x has gone up. So, intuitively you know that if the price of x goes up, by law of demand consumption of x should go down, you know that. So, you know that this cannot stay here, this has to be somewhere on the left hand side of that point, correct? But you do not have any idea about what should happen to this point, you do not know yet. So, now you need to use your brains there and see Px is not involved here at all. This point is just about m by py, the x coordinate is 0 and the y coordinate is m by py. So, m by py cannot be affected by any change in Px, isn't it? How much of good y you buy cannot be affected by the price of good x. Good y does not have any bearings. We did not say that these are related goods or anything, right. To start with, we did not make any such assumptions. This could be shoes and apples, this could be airplanes and designer clothes. They could be absolutely unrelated goods. So, whatever happens to the price of x can have law of demand applied to the quantity demanded for good x, but it cannot have any bearings on good y. Do you see what I am saying? So, that means this point is going to remain fixed. This point is going to remain fixed. What is this? None of them are working. Okay, thank God. So, that point is going to remain fixed, but you are going to consume less amount of x, something towards the left, right. So, that means whenever the price of x goes up, you have a tilt or a rotation of the budget line, something like that. It is an inward swing of the budget line along the x axis. Do you see that? the y-axis remaining fixed. It is an inward swing of the budget line, anti-clockwise swing of the budget line along the x-axis. Is that clear? Did everyone follow why that happened? Bought less apples, yes, without any change in oranges. So, we can say budget line swings in. Now, what is this x-axis? Please be aware about this. By x-axis, I mean the axis along which you are measuring the good x. Do you see what I am saying? If I was measuring apples there on the vertical axis, then it would not look like that. Then it would look the other way. It would remain fixed here and it would swing in the other side if I interchange the axis. So, by x, I do not really mean the horizontal axis. I just mean the axis along which you are measuring that good x. Right? Now, if the price of good x goes down, then obviously by law of demand you will be having more of good x. Once again, it does not have any bearings on good y because Px is not involved there, right? That you would be consuming more of the apple. So, that means your budget line would swing out like that. So, this would mean budget line swings out and once again by x axis I mean the axis along which I am measuring the good x, does not mean the horizontal axis always, because like I told you I could be measuring apples on the vertical axis there.
But you're still spending your entire budget because of the price increase? Gotcha.
Nothing has happened to the budget yet. I am still spending m. Constraint is still there. Okay. Now, similarly, I can have two more cases. I can have a change in Py. So, Py increase and I can have a Py decrease, right. You please draw another diagram, I will do it in the same one. You draw another diagram. Okay. So, if I have an increase in Py, obviously my consumption of y has to go down by law of demand. Quantity demanded for y will go down. No bearings on x because nothing has happened for x. Price of x is still the same, money income is still the same, there is nothing else happening. So, I just have to consume less y. So, that means now my budget line will look like that. So, once again here budget line swings in along the y axis. So, now it has to swing in along the axis where you are measuring the good y, where you are measuring the oranges. Okay. And similarly here, if the price of y went down, then you would be having more y and nothing else has changed, the income has not changed, the price of x has not changed. So, you would have something like that. So, your budget line swings out. Okay. So, that means you can summarize this by saying whenever there is an increase in the price of the commodity, this is the important part for you to remember, that if there is an increase in the price of the commodity, then the budget line will always swing inside, right, and it will always swing inside along the axis where you are measuring that particular commodity, assuming that nothing else has changed. Nothing else, I mean the price of the other good and your money income. Okay. But now what happens if money income itself changes? That can also happen. The prices do not change, but your budget itself changes. So, M has gone up or M has gone down. That is also possible. Your income increases or your income decreases. What will you do? What do you usually do when your income increases? What?
Spend more.
Spend more. Why? Now you have done demand and supply. So, you have to talk in terms of demand and supply. You have to talk a little bit in economic terms. If income rises, what happens? Your demand changes, right? Assuming that apples and oranges are both normal goods, you will be consuming more of both if your income rises, isn't it? Because nothing has happened to the price of apples and nothing has happened to the price of oranges. Just that you are now, instead of earning $100, you are just earning $200. So, if the price is still $5 per unit, now you can, buy 200 divided by 5 of apples and 200 divided by 5 of oranges, which is more. So, that means without any change, once again I will do it here, you can draw another one or do it in the same one, whatever suits you. It just means that this person is going to consume more of apples and more of oranges, more of both, assuming they are both normal goods. That means with an increase in income, the budget line is going to move out and the budget line is going to move out parallelly. Okay, and I will tell you why in the previous case we were considering a sloped, a swing, and here we are considering a parallel shift. I will tell you that in a bit. Okay. Similarly, if the income went down, if there was a decrease in income, you would be consuming less of both the goods, isn't it? So, in that case your budget line would move in like that, correct? And also mathematically that is correct. Why? Because this point is getting affected because it has M in the numerator, and that point is also getting affected because it has M in the numerator. So, both those points must change mathematically also if M changes, because the numerator would change in both cases, correct, even if the denominator stays the same. Now, the next question that we come up to, so here we can say budget line shifts out and budget line shifts in. Now, the most important question, that why in the previous case we were not considering a parallel shift. Is there a mathematical reason to that? Yes. Why? Now, this is a straight line that we are drawing. This budget line is a straight line, and that formula that we had on the board, Px times x plus Py times y is equal to m, that is the equation of a straight line. So, to find the slope of that straight line, what is the slope of a straight line? Rise over run, correct? Change in y divided by change in x, everybody agrees? So, if I have to, let us say I have this original budget line, this is my original budget line, okay, the one in between. For that original budget line, I have 2 points. I do not know any other consumption point, it is not given to me. I just know that this point is 0 divided by m by Py, and I know this is m by Px 0. I just know those 2 points. If I ask you find the slope of that line between those 2 points, can you find it? How will you find it? The slope will be change in y. So, the change in y, I am looking at these 2 points A and B. So, change in y would be m divided by Py minus 0, right? Is everyone following? And divided by the change in x, that is 0 minus m by Px, isn't it? So, the slope will come to, the slope of the budget line, if I simplify that, will come to minus Px divided by Py, right? Did everyone understand? I am just doing rise over run between those 2 points. Change in y divided by change in x minus Px by Py. So, the slope of the budget line is always, that slope is always negative Px by Py, where the negative sign just means that that line is downward sloping. It's a downward sloping line, that's why you are getting that negative sign. Let's not go into the details of that, the mathematical details of that. Okay. So, the ratio of the prices of the two commodities is basically the slope of the budget line. You must remember that. Intuitively, that is what you should remember. The ratio of the prices of the two commodities, that is the slope of the budget line. Okay. So, now when we were considering this first case and we were saying that Px goes up, what happens to that slope? If only Px goes up, what happens to that slope? Does that slope increase or decrease? The value goes up, right? If the numerator goes up, then the fraction increases in value with no change in the denominator. That is exactly what happened. Flip your page and see. In the first diagram, when you rotated the budget line inside, that rotated budget line is a steeper budget line than the previous one, isn't it? Can you see that? When you rotated it in like that, that rotated line has a steeper slope. That's exactly the reason. Okay. Similarly, if the price of x goes down, then here the numerator is going down with no change in the denominator. So, if the value of the numerator goes down without any change in the denominator, then the fraction reduces in value. Correct? All of you agree? So, that is exactly what was happening when the budget line moved out. The rotated budget line, look at your diagrams, I am not drawing it again, look at the second diagram. The rotated budget line looks flatter than the original one. Yes? Similarly, for Py, you will see the same thing. When Py increases, the denominator is increasing without any change in the numerator. When the denominator of a fraction increases without any change in the numerator, then the fraction as a whole decreases in value, isn't it? 3 by 2 is bigger than 3 by 4. If the denominator increases, then the fraction decreases in value, correct? Same for Py going down. The denominator going down with no change in the numerator would mean that the slope would be increasing as a whole, that fraction. Okay, this is mathematically true. This is no economics. If you think about it, if you spend 2 minutes, if you are having problem in getting that, if you spend 2 minutes at home about it, if you think about it, you will get it. Okay, if you put some numbers to it and try to get it, you will get it. This is not econ, this is just math. Okay. So, basically your takeaway from this, after all that we have done, your takeaway are those 4 points and the slope. So, all you need to remember is that when you have a budget line and you have a budget constraint and you draw that, the slope of that budget line is the price ratio of the two goods, and if the prices get affected, that means if the prices change, then you have a shift of the budget line as in a rotation inward or outward. And if you have a change in the monetary income without any change in the prices, then you have a parallel shift of the budget line inside or out. Now, one last case, what will happen, and I am not writing this, I am just asking you, what will happen, what do you think will happen if everything changes in the same proportion? So, the price of x is changing, price of y is changing, and money income is also changing, but they are all changing in the same proportion. There will be no change because everything will cancel each other out, right? Because here m by Py, m is increasing 2 times, Py is increasing 2 times, cancel, same, cancel. So, everything gets cancelled out and the budget line will not change. So, you can keep a note for yourself that if everything changes in the same proportion, if all 3 variables m, Px and Py, they all change in the same proportion, then you do not have any change in the budget line. Okay? Now, coming to optimum consumption bundle. So, this was about budget line. So, we are done with budget line, we know what is the slope of the budget line, and we know that how the price of the two goods and my money income, how that can affect my budget line. Okay. Now, the next part is, so we were talking about consumption bundle. Now, how do I know consumption bundle? So, one part is budget, One part is purchasing power. I should have money and I should have a budget, and given my budget I have to make my choices. But there is also something called preference. I may have money income 100, you may have money income 100, she may have the same money income 100. I decide to buy only apples, you decide to buy only oranges, she decides to buy apples and oranges. Possible, right? And she may also decide to buy apples and oranges, but she may have more apples in her basket than her. But we all have the same money income. So, even when we are constrained by the same income, every individual can be different, and this difference is created by the preference of the individual. Every individual could have a different preference, although the prices they are facing in the market is the same Px and Py, the same income in their pocket. Possible, correct? So, that means there must be something to show, there must be something in this diagram to depict the preference of a consumer, right. So, the graph that we use or the curve that we use for showing the preference of the consumer is called an indifference curve. Indifference curve, simply called the IC. So, this indifference curve is a curve which shows the preference of the consumer, okay, and that preference is also plotted in the same space. So, you still have the quantity of one good measured here, and you have the quantity of the other good measured there. Once again, you could interchange between the two, okay, and the indifference curve just goes through all different consumption bundles. So, this is a curve which looks like that. So, it is always convex to the origin, okay, it is convex to the origin, that curve, and it passes through all the points. So, there could be numerous consumption points on that space, right, which all shows different combinations of x and y. And if you draw that curve, you are obviously drawing that curve through certain points, through certain consumption bundles that could be there in that space, correct. When you draw that, it just means that any point that is there on this indifference curve, the consumer is indifferent between those points. So, if I am a person, I could have bought this, that means so much of x and that much of y, or I could have bought here, which means I could have bought that much of x and that much of y, but I would be indifferent between those 2 points. That is what it means. So, it just shows the preference of the consumer such that all points on one particular indifference curve just shows the different consumption bundles for which a consumer is indifferent. The consumer does not have a strict preference. Okay. In other words, what am I trying to say? I am trying to say that all these consumption bundles, all these combinations of x and y give the consumer the same amount of utility, otherwise he would not be indifferent, isn't it? If something gave him greater utility, then he would have a preference for that, because at the end of the day all consumers are rational, they want more benefit than less benefit. So, that means all these points give the consumer the same amount of utility. Let us call that utility U1, it could be 5, 10, 100, whatever, some value, right. Now, if you have another indifference curve which lies above the previous one, okay, you still have different consumption bundles there. You can still have different consumption bundles on that indifference curve, and it would just mean that these consumption bundles which I am marking with x, all the consumer is indifferent between these consumption bundles because they lie on the same indifference curve. That means they give him the same amount of utility, isn't it? And that utility is given by U2. So, I know that if I have to choose between A and B and I am the consumer, I cannot choose, I am indifferent. But my question is, what about B and C, which lie on different indifference curves? Is there a strict preference? Yes. Any indifference curve which lies above or the right hand side, provided that the indifference curve is convex, and for you, I am not doing any other kind of indifference curve, it is just convex indifference curve for you. So, for you, the general rule is when the indifference curve lies to the right hand side or on the top of the previous one, that is a better indifference curve. In other words, a consumer will always prefer U2 over U1. Anything that lies on U2 will be preferred by the consumer than U1. Okay? Similarly, if I had another indifference curve U0, then for the points on U0, the consumer will be indifferent. For the squares, the consumer will be indifferent because they are all lying on the same indifference curve. But the consumer would not want to take U0 if he can take U1, because U1 is lying to the right, isn't it? So, he would rather take U1 than U0. Do you see what I am saying? So, always a consumer will want to take an indifference curve, will want to take a consumption bundle that lies on a higher indifference curve, because a higher indifference curve just means higher utility. Is that clear? Got it? Yes or no? So, if I ask you to compare between U0, U1 and U2, U2 will always be more preferred than U1, always more preferred than U0. And that will be true for any consumption bundle on U2, that will be true for any consumption bundle on U1, that will be true for any consumption bundle on U0. I hope you understand by consumption bundle I am trying to mean a combination of apples and oranges, a combination of x and y, some amount of x, some amount of y. Okay? Is that clear? And similarly, you know, if that is true, then U0 is less preferred, that is also true. It is true in the opposite direction also. So, U0 is the least preferred one here, U2 is the most preferred one here. Okay? Now, what is this indifference curve giving me, or in other words, what is the slope of this indifference curve basically? What am I trying to see through this indifference curve? It is depicting preference, but it is depicting preference between, it is depicting the preference for a combination of the two goods, right? So, the slope of the indifference curve basically gives you, if you took the slope of that curve, then that slope of the curve is basically called marginal rate of substitution, MRS, of any indifference curve. The slope of any indifference curve is called MRS, which is marginal rate of substitution, marginal rate of substitution. Okay. And what is this marginal rate of substitution? The marginal rate of substitution is the rate at which you substitute between two commodities, these two commodities x and y. Okay. Now, please note if say I have this indifference curve U1, so I said that if I have 2 points like that, then I am indifferent between those 2 points, isn't it? But please note that at this point I am getting more of x and I am getting less of y, isn't it? Whereas at this one I am getting less of x and I am getting more of y. So, that means there is some substitution that is going on between the two commodities to make me indifferent between those 2 points, isn't it? In other words, can I say that if I am going from this point to that point, that means when I am gaining this additional amount of x, it is okay for me to give up that amount of y? Can I say that? That is exactly what is happening. If I am traveling from this point to that point, then I am gaining that extra amount of x, right? But while I am gaining that extra amount of x, I am having to give up that amount of y. And if I am indifferent between those 2 points, that means that I am okay with that. I am okay with that rate of substitution. Do you see what I am saying? So, the slope of the indifference curve basically shows you the rate of substitution between the two goods for which you would be indifferent. The rate of substitution between two consumption bundles. Okay? And when will you be okay? When will you be okay with the rate of substitution? You will be okay with that rate of substitution if the marginal utility that you gain from an additional unit of one good, marginal utility that you gain from one additional unit of x can be replaced by the marginal utility that you give up by giving up one amount of y. So, it should be equal to mu x by mu y, because we take all decisions based on the margin, right. So, everything has to boil down to marginal. You will be okay with the rate of substitution, you will be okay with, you will be indifferent only if the marginal utility that you gain from one additional unit of the one that you are getting is similar to the marginal utility that you are losing on the other side by the loss of one unit of the other. Okay. So, then marginal rate of, that means the slope of the indifference curve is basically nothing but the ratio of the marginal utilities of the two commodities. It is the ratio of the marginal utilities of the two commodities, okay. And the slope of the indifference curve is this. Okay. So, now we know what is indifference curve. So, now we have got two concepts. So, one side we have seen that there is a budget line. So, an individual has a budget line and an individual has a preference which is given by indifference curve. So, now I will bring the two together. So, I still have quantity of x, I still have quantity of y, I still have that budget line, and all those points still are the same, I am not writing them, okay. And I have tons of indifference curves that are possible, okay. Let me call them u1, u2, u3, u4, okay. Based on our discussion that we just did, you know that u4 will always be preferred than u3, will always be preferred than u2, will always be preferred than u1, based on what we just said, correct. So, that means if given an option, if I asked you which indifference curve do you want to choose, which one will you choose? The highest one, you will want to be on u4. But please note that even when you want to be on u4, you cannot be on u4 because your budget is not permitting you to take anything that is on u4. That is what we just said when we did budget line. We said any consumption bundle that lies outside the budget line, you cannot achieve it with your budget unless your income increases. Unless that income increases and your budget line parallelly moves out, you cannot achieve it. So, given the same income, you cannot. So, you cannot get that. Which one will be your next preferred one? u3. Now, can you get a point on u3? Still no, it is still outside your budget. Next preferred one, u2, right. Now, can you get something on u2? Can you get u2? Yes. But now what is the problem? The problem is after you get something on u2, you still have more money left. And humans, they are, their wants are unlimited, unsatiated wants. So, as long as I have money in the pocket and my system tells me that, don't save, you cannot save, I will want to spend it. And while I spend it, I will want to get maximum utility, more utility. So, that means the ideal for any individual is the indifference curve which is tangential to the budget line at exactly one unique point. So, that means a person will keep trying to improve his utility, he will try to go on higher and higher and higher indifference curve, and that will continue till the indifference curve which just touches the budget line at one unique point. Because if you try to take the utility any further higher, you will be outside your budget line, and if you try to take the utility any lower, then you will be making some savings. So, the best case scenario for you is this indifference curve u star, which gives you higher utility than u2, but less utility than u3. Okay. So, u2 is less preferred than u star, less preferred than u3, but it is still the best one or the optimum one for you. Why? Because given your budget constraint, this is your most preferred one. You would love to take U3 and if possible even U4 or U infinity, but you do not have money in your pocket, you are constrained, correct. And sometimes, and at this point let me tell you which is what we are going to use in the later chapter, sometimes this constraint may not be money, this constraint could be time, right. So, if your choice is between sleeping and working, you would probably want to sleep all 24 hours, but then you cannot because you have to earn money. So, you have to go to work. So, then you have to choose between how much work and how much sleep, but you cannot extend that 24 hours. Given the 24 hours, you have to do what is best, you have to make the best choice. Do you see what I am saying? So, that means the best indifference curve, in this case the U star, is the one which is tangent to the budget line at one unique point, just one point. By tangent I mean it just touches the surface at one point. Okay. So, can I say that the optimality condition, the optimum consumption bundle will lie on U star given M or given the budget constraint, okay. And that tangency point need not be always at the middle, it could have been something like that, it could be there or it could be here, but it has to be one unique point of contact, not always at the midpoint, just one unique point of contact. Now, mathematically what does that point of contact mean? What does a tangent mean? Tangent just means that you are touching two surfaces just at one point, it is just a very subtle point of touch. What does that mean? That point means that at that point those two surfaces have exactly the same slope. If you are taking the slope of that line and the slope of that curve at that point, they overlap, it is the same mathematically. One is a linear surface, one is a line, other one is a curve, but just at that point the slope of that curve overlaps with the slope of the line. It basically that line becomes that slope of that curve at that point. Okay, this is once again not economics, it is math. At a certain point of contact, the slope is always the same of two surfaces. Whether the surfaces are, it is a curvature or a straight surface, that does not matter. So, that means can I say that at the optimum consumption bundle, slope of BL, that is the budget line, is equal to slope of IC? Can I say that? Because those are the two surfaces, one is the straight line, that is the budget line, the other one is the curve, which is the IC, the indifference curve. So, at that optimal consumption bundle, which is this one, the tangency point, the two surfaces have the same slope. Now, I know that the slope of the budget line is the ratio of the prices. So, minus Px by Py, okay, where that negative sign, I just got that negative sign because that line was downward sloping, it does not have any other meaning, right. The negative sign just shows me or tells me that the budget line is downward sloping, that is it, no other information, right, is equal to the MRS basically, where MRS is equal to MUX divided by MUI, that is what you just wrote. The slope of the IC is nothing but the MRS, where MRS is this, isn't it? Yes? So, can you see that this is the mathematical formulation for the optimal consumption bundle? If I ask you, if I give you any three, you can find the fourth one using this and hence get the optimal consumption bundle, right. So, that is where we will stop today.